Hello everyone, and there you find yourself reading chapter 15 already. And this is also the chapter that we're going to discuss in this lecture. Importantly, so far we studied markets in isolation, and this week we are going to look at markets that are interconnected. We're also going to look at social welfare functions, at the concept of Pareto efficiency. When can we claim that a market operates efficient, and what measure do we have and use to measure efficiency? And we're look at exchange efficiency in markets, and we're going to discuss two fundamental theorems of welfare. So, what is their meaning and what are their implications? When you consider a market in isolation, as we have done so far, we call this partial equilibrium analysis. You look at the equilibrium in that market only, and you assume that it's isolated from any other market. But in the real world, most markets are linked. If there's a demand shock or a supply shock on one market, that often not only has implications for the equilibrium in that market, but also for the equilibrium outcomes on other markets. And this is what we're going to study in this chapter. For example, if there's an increased labor demand from one industry, then it will increase the wage for all workers, regardless of the industry that they work in. So, as an example, at the moment, the government needs a lot of people for the vaccinations, so they hire a lot of people. But now the pubs have reopened and there's a shortage of personnel for staffing the pubs and to supply people with the drinks on the terraces. So here the labor market is important in both markets, and a demand for labor in one market has implications for the price of labor in other markets as well. And ultimately also it has implications for the price of your beer. So in this chapter we introduce what we call general equilibrium analysis. And this is the study of market behavior that incorporates cross-market influences to determine the equilibrium. And let's start with an example. So this is again a mathematical model with equations, and we're going to solve this. So suppose that demand for corn is given by 20 minus PC, which is the price of corn, plus PW, which is the price of wheat. And here already you see the new element that the demand for corn, the quantity demanded, not only depends on the price of corn, but also on the price of wheat. And there's a plus sign here. You can see that an increase in the price of wheat increases the demand for corn. So apparently these two are substitutes. And the demand for wheat is given by a similar equation. So the demand for wheat is given by 20 minus PW. So it's decreasing in the price of wheat, but increasing in the price of corn, plus PC. And the supply of each is a very simple equation here. It's upward sloping in price, as we would expect, but the supply function is just identical to the price. So the supply of corn is identical to the price of corn, and the price of wheat determines the supply of wheat. So we have two markets here, the market for corn and the market for wheat, and we have to determine the equilibrium price and equilibrium quantity in both markets. And as you can see, these two markets are connected in their demand functions, because the demand in one market is also dependent on the price that establishes on the other market. So let's do this. What is the equilibrium price for wheat? So we have this demand function for wheat and the supply function, and in equilibrium, supply needs to equal demand, just like before. So when we equate the two and we solve, then we get an expression that still contains one or two unknowns. So if we solve this resulting equation over here for the price of wheat, we see that the price of wheat is positively dependent on the price of corn. But at this point, we still don't know the equilibrium price of corn, and we don't know the equilibrium price of wheat. But if we know the price of corn, then we would also know the equilibrium price of wheat. So how to make progress here? Well, realize that here we derive this equation by only looking at the supply and demand for wheat and equating the two. And that gave us one expression with two unknowns, the two unknown prices. But what happens if we do the same for the market for corn? So the equilibrium price for corn is also establishes by equating the supply and the demand for corn. So here we have the demand for corn, here we have the supply of corn. When we equate these two, then we arrive at an expression that gives us the price of corn as a function of the price of wheat. So PC is 10 plus PW over 2. That is our second equation. So now we have two equations with two unknown prices, and we can solve this. So these are the two equations that we derived by equating supply and demand in each of the two markets. And now we can insert the expression for the price of wheat into our second expression in the PW. So we replace the PW in our second expression by the expression that we obtained for the price of wheat in the first equation. So of course you can do it the other way around. You could also choose to replace the PC in the top equation by the expression at the bottom. But let's do it like this. So when we insert the 10 plus PC over 2 into this expression where currently there is this PW, and we get this expression here in the top. And when we simplify, then you arrive at PC is equal to 10 plus 10 over 2, so 5. 10 plus 5 is 15. And PC over 2 divided again by 2 is PC over 4. And we can solve this expression for PC by bringing this term to the left-hand side, and you get PC minus 1/4 PC gives 3/4 PC needs to equal 15, and solving for PC gives you the equilibrium price of corn being equal to 20. So when the equilibrium price of corn is 20, then we can easily derive the equilibrium price of wheat, because we already have a function that gives us the price of wheat as a function of the price of corn. So we simply replace the PC over here by the 20, and you get that the equilibrium price of wheat is 10 plus 20 divided by 2 is 20 as well. So both the equilibrium price of corn and wheat is 20 in this case. Of course, it's a coincidence that they are both equal to 20. This is just a result from our expressions of the demand and supply functions in the two markets being very symmetric. If you would make them less symmetric, then the equilibrium prices would probably also be different. And now you can plug in the equilibrium prices in either the demand or the supply function in each of the markets. Again, it doesn't matter which one you take, because in equilibrium supply equals demand. So we had these very simple supply functions saying that the supply of wheat is identical to the price of wheat. So it makes sense to use that one in order to derive the equilibrium quantity of wheat. So equating that gives us that the equilibrium quantity of wheat is 20 million bushels, and the equilibrium quantity of corn is 20 million bushels as well. And that completes our practical application. So this is the first example of general equilibrium theory that you got, and this is pretty straightforward. So it's a very useful tool, because in this way we can compute the effects of a change in one market, so a shock to the demand or the supply in one market, on the equilibrium outcomes in another market. And we did here an example where the dependency between the two markets was via the demand functions. So the demand for one good positively dependent on the price of the other good, the price in the other market. Of course, you could just as well let this interconnectedness run via the supply function. But How you model it in practice should depend on the real life phenomenon that you have in mind. So does it make sense that supply is interconnected, or does it make more sense to model demand as being dependent on each other? But in solving, it doesn't make a difference. It's conceptually the same. And this already brings us to the first quiz of this lecture. And as you will see, it's very similar to the example, but it's a little bit more intricate here because we have, again, two markets. So we have the market for rice. The demand for rice, again, is not only dependent on the price of rice, but also on the price of potatoes, which is the second market that we consider. And likewise, the demand for the potatoes is not only dependent on the price of potatoes, but dependent on the price of rice as well. But to make matters a little bit more interesting, we have here an example where also the supply of rice and potatoes is dependent on the price that establishes in the other market. So the supply function of rice not only depends on the price of rice, but also on the price of potatoes, and the supply of potatoes also depends on the price of rice. You already can see by the way this problem is set up that the demand and the supply functions in the two markets are again very symmetric. So you would expect that if you would solve this problem, the equilibrium price in the market for potatoes would be identical to the equilibrium price in the market for rice, and also the quantities will be the same. But I leave it up to you to determine what that equilibrium price and what that equilibrium quantity in both markets are.